Okay. So even after active safety system, our building is going to have a larger fire. Then what is the last line of defense? That is, our building has to be controlled from collapse. There has to be passive systems. The passive systems are it is a very important element. We call it as in BRC or maybe in bark. We call this as defense in depth. There are so many barriers. Okay, out of all the barriers, if that fire has taken up to become a bigger one, the last line of defense in that compartment is this passive systems. Basically, any of the material that we consider for construction of the elements, it should be fire resistant. Okay, and they should have the ability to stop the fire and should not create any smoke. These are the main requirement under these conditions, and these are some of the elements as I have given here. It could be columns, beams, or it could be the compartment wall elements. Some of the industrial structures require some of the steel or partitions has to be provided. In that condition, it should ensure that fire should not travel beyond that limit. And the ducts, or it could be the barriers that we are going to provide around any of the duct and means of egress. These are all some of the elements which we call it as last line of defense, has to protect our building, and also any of the external persons to get inside to safeguard the life inside and control. What our NBC gives for this passive safety system, as I told you, NBC building code, it has the prescriptive guideline. Again, you might have seen IS 456, where if you provide 40 cover, you will reach 30 minutes to 4 hours of fire resistance for my column. Suppose if you provide 200 of the width in the beams, you are going to achieve about 1 hour, 2 hours of fire resistance. This is the limitation. What is being provided in our NBC, or it could be any of our building guidelines. It is not that it is bad. It should not be generalized, because there are greater structures are coming, new materials are being utilized, and it has to be made it even that for that performance-based analysis. So, okay, basically in NBC, all these elements, whatever this I have added to the left side of this slide, fire resistance, columns, beams, walls, or it could be the firewalls. Okay, it could be RC firewalls, and the barriers or any of the duct that we are going to provide, it should have minimum fire resistance. And if you provide that, any of the geometrical parameter, you are going to achieve that fire resistance rating. But is it right? Is it good? No. It is generalized for smaller to medium-sized buildings or smaller spaces. It is good. Larger instances, we may have to follow performance-based design. Even for passive fire safety, we have performance-based design. We call it as PBD. Let us look into PBD, what we have in PBD. Okay, this is one of the table that I have put up in the slide. Hope it is visible. Table 2. This is prescriptive guideline. This is prescriptive guideline. Basically, if you provide for a reinforced cement concrete 120 thickness, you will achieve 1 hour fire rating. Okay, this is good for RCC, but not for material that we are introducing into the RCC. There are greater material of higher strength we are getting, UHPC, HPC, or maybe high density concrete. These are all some of the new material that we are adding. Whether these materials also are going to hold the same fire resistance? No. No. So in that condition, we may have to go for performance-based design. Where we have this performance-based design? Do we have it in India, Indian code? No, not yet. We have it in ACI. We have it in Eurocode. Okay, where we are considered the realistic fire scenarios. These codes are going to provide opportunity to select the fire environment, and we could literally model the fire as per the design requirement. That is the extent of code provisions that are there in ACI or EN. And we have to select the material based on the temperature or thermal condition that we are going to do. We have to select the material, and material behavior should be acting accordingly, and determine the structural stability, and time based performance has to be adopted for the passive system. This is what we have to do, and this is good, but this is always good. Okay, so when we do the performance based design, we have the complete control over each and every element that we are going to construct in the building. So I'm giving you one of the scenario where I have analyzed using this PBD in the abacus. In abacus you can see the beam analysis, the fire environment, the bottom x and y axis that will show the time temperature curve. So basically, this is a standard fire curve. We call it a standard fire curve. Okay, the black color one, which you are seeing here. Okay, so basically, this temperature is being exposed to this beam element. Okay, under the action of this fire, along with the load, what is the performance of this beam will be analyzed. Okay, and similarly, we can also do the compartment analysis of the steel structures. So this is one of my analyzed structure for the traveling fire mechanism, though it is exaggerated, but this is what the type of analysis we have to perform for steel structures. Suppose if the fire is going to travel from one end to another end, suppose if it is a bare structure without having any protection, what is the type of failure that it is going to occur? This has to be determined. Okay, and these scenarios, this is an exaggerated one. This is an exaggerated one. So under these scenarios, we have to analyze our building and come out with a passive system which is going to resist the type of fire that is going to develop in the future.